Hi, my name is Nurul Fatih Adina Binti Juli. With the rest of my team member, we would like to present our study regarding diabetes in Pima Indian women. So let's start with the introduction. As the diabetes problem continues to rise and increasingly affects individuals and children, pregnant women have a higher risk of acquiring diabetes during pregnancy. In recent years, the prevalence of diabetes has significantly increased over the world, and this has in turn impacted on the incidences associated with many complications. So our objective, number one, is to measure the appearance in the subsequent generation of mothers with pregnant diabetes. Number two is to identify the contributing factors of diabetes among Pima Indian women. And number three, to identify the causes and risk predictive factors associated with type 2 diabetes in Pima Indian women.
So the demographic profile. The first graph shows that this is a distribution of age. It shows that the highest respondent is 24 years old and the lowest respondent is at 52, 54, 57, 58, 61, 65, 70 and 81 years old, which is 2 women out of 332 women. And the second graph shows that this is the distribution of numbers of pregnancy, and it shows the highest respondent is one pregnancy, which is 71 women out of 332 women, and while the lowest numbers of pregnancy is 15 and 70 pregnancies.
Coefficient table show that the independent variable there are no significance are blood pressure, thickness of skin since the p-value is greater than alpha 0.05. Below are the first full linear regression model. From R-square value, there are 31.74% total variation in concentration of glucose can be explained by all independent variables, and the other 68.26% of total variation is explained by other factors. Based on the ANOVA table shows that the model is significant since the p-value 0.001 is less than alpha.
For efficacy checking, we first check the linearity of the variable. First scatter plot shows that there is no relationship between the number of pregnancies and the plasma glucose concentration. That leads to no linearity. Second scatter plot also shows that there is no relationship between the diastolic blood pressure and the plasma glucose concentration. Therefore, it also leads to no linearity. Next is the scatter plot shows that there is a relationship between the triceps skin fold thickness and the plasma glucose concentration. Therefore, it shows the linearity. Next, the scatter plot shows that there is no relationship between BMI and the plasma glucose concentration. Therefore, it is non-linearity. Last but not least, the scatter plot shows that there is no relationship between the age and the plasma glucose concentration. Therefore, it also leads to non-linearity. For checking the normality, we use QQ plot of residual for plasma glucose concentration that shows that the error terms are normally distributed because almost all points lie on the 45-degree lines on the QQ plot. For checking the consistency of the error variable, we use QQ residual by predicted for plasma glucose concentration, which shows that the error variance is constant because there are only 2 points near in the scatter plot of residuals against fitted value, hence it is homoscedasticity.
Darby-Watson shows that the error terms are independent and no serial correlation exists in this dataset since the value of Darby-Watson is 1.994, which is in the range of 1.5 to 2.5. Based on the parameter estimate shows that the multi-coronative problem does not arise since the tolerant value for each predictor's variable is greater than 0.2. Other than that, variant inflation factors also shows that there are no multi-coronative problem since all the values is less than 10. Correlation of estimate shows that the multi-coronative problem does not exist since all the pairs of independent variables with a correlation coefficient values is less than 0.5. Based on this scatter plot for outliers, it shows that there are a few leverage points that exist outlying cases with the X value. For the cruise distance, it shows that there are influential cases in the data series since there are some values above the boundaries.
This is part B. First step, we remove the variables that are not significant. From the coefficient independent variables table shows x2 and x3 are not significant since the p-value of two variables is more than 0.05. Therefore, the two independent variables need to be removed from the model. Second step, transform independent variables. Since three variables are significant, then we transform three independent variables. For x1 we transform the variable into square root x1. We use natural log to transform the variable x4 and x5. It makes some difference on scatter plot. Step 3. Transform dependent variable. We transform the dependent variables to make the variable significant. We choose the square root of y to transform, therefore it makes all the variables significant. And the last step, remove outliers. From the closely distant residual of all cases have changed when the particular case was excluded for the calculation of the aggregation coefficient. The rule term for this model is shown in the slide. We remove the outlier points which are at under the limit. The observation that have been removed 4, 5, 31, 45, 79 and others observation. For final model, after eliminate the two variables that are not significant to the regression model, we do some transformation to the certain variables and eliminate the outliers. The best fit of the regression model that fulfill all the assumption was obtained by the researcher. And here are the final full linear regression model.
Based on ANOVA table, it shows that this model is a good fit model since the p-value is 0.001, which is less than 0.05. For the R-squared value, there are 49.23% of the total variation in concentrations of glucose can be explained by the number of pregnancies, BMI, age, and the presence of the diabetes. The other 50.77% of the total variation is explained by the other factors. For the R-squared adjusted also shows that there are 48.51% of the total variation in concentration of glucose can be explained by the number of the pregnancies, BMI, age, and the presence of the diabetes after considering the number of the samples and the number of parameters, while the balance 51.49% is explained by the random error. For the final model, it shows that all the independent variable is a significance variable, since all the p-value is less than 0.05.
For adequacy checking, we first check the linearity. The first scatter plot shows there is a positive linear relationship between the concentration of glucose and the number of pregnancies. The second scatter plot shows there is a positive relationship between the concentration of glucose and the age. Next scatter plot shows there is a positive linear relationship between the concentration of the glucose and the body mass index. The QQ plot used to check the normality. The QQ plot shows the error term are normally distributed. The QQ plot is a short tail because an S-shaped curve indicates shorter than normal tail, less variance than expected. It also shows that almost all the points lies approximately on the straight line at 45-degree line.
Consistency of the error variance. Figure 4.3.8 shows that the error variance is constant because there is no pattern in scatter plot of residual against fitted value, hence it is homoscedasticity. Independence in the error terms. Based on Durbin-Watson for the above table, it shows that there is no serial correlation problem in the model since the Durbin-Watson value is 1.971, which is 1.5 to 2.5. Multicollinearity. Based on the tolerance statistic value TOL in the above table, all values in the column are more than 0.2, thus this indicated that the multicollinearity problem does not exist. In addition, no value in the variance inflation column is more than 10, hence we can conclude that there is no multicollinearity problem in the dataset.
So what we can conclude from the analysis that we get, at first the model is not a good model since there is some variables are not significant, but after we have done identifying the variables and make a transformation and also we made some modification, the final result shows that the model is a good model and adequate since p-value is 0.0001, which is less than the value of 0.005. Linearity shows that there is a positive linear relationship between the predictor variables and the response variables. And the error terms are normally distributed. Meanwhile, the error variance also is the consistency, and there is no multicollinearity in the dataset.